Right, thank you.
There it is.
Who's ready for some structure and order? Great, well, you've come to the wrong place. It's lightning talks time. Yay! Okay, for those of you who've been here before, you don't need to listen to this. For those of you who haven't, these are 5-minute talks that people have signed up for today. They will be presenting with or without slides on whatever topic they decided was interesting and we agreed was interesting. And our job is to make these go fast without awkwardness in between.
We'll do our best on the awkwardness thing, but, you know, lightning talks...
I'm audible, really, I am. They can hear me.
Lightning talks are chaotic for myself and Chris. They're chaotic for our presenters. They're chaotic for our AV team, as you've already seen. But they are also loads and loads of fun.
Okay, and so part of this is audience participation. We need to make sure that our speakers who signed up for 5-minute talks do not get any more time than what we let them have. Our speakers can see a timer on the front of the screen, and Benno here is managing the timer, and when we get to about 10 seconds left, he's going to start finger clapping silently, relatively quietly, so it doesn't drown everyone out, until he starts applauding a bit more. And then when the clock fits 5 o'clock, we are going to applause uproariously and cheer really, 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 really loudly until we say stop so we don't waste too much time. Okay, so on deck we have David Vo, but first, Amanda Hogan.
Stop.
Okay, I need screen. Yay, okay, so I have in front of me, I have 3 pipe cleaners. I've cheated appallingly by cutting one of the pipe cleaners into with 2 cuts into 3 pieces so that I didn't take a whole minute, which I've just used to explain to you. So what I'm going to be doing is talking about how you can make earrings out of everything. While I'm talking, I'm also going to be making earrings out of pipe cleaners. When I was very young, I don't know how many are like me, I used to hang cherries in pairs over my ears at Christmas lunch. Has anyone done that? Yeah, okay, so this is my first foray into earring making. I believe that it was a craft. And so after that, my mum refused to give me pierced ears, so I then dangled Christmas baubles and their long string over my ear. I was told that I was not allowed to get pierced ears until I was 16, when I was allowed to go without parental consent. Very nice of her. And then, when I was in year 11, I did get pierced ears. My school added a Coke machine for fundraising purposes, which is a terrible idea. I don't know. And so, do you know that if you remove the tab from a Coke can a very careful way, it has a hole that can be threaded through a stud earring or a sleeper. Sleepers will come back, so you have to know what they look like. That's a sleeper. And then you can really annoy some private school teachers. And so that was... then I discovered that Christmas earrings that I really loved were things that people... That's one. We have a butterfly, everybody. Christmas earrings were a thing that people paid money for, and I didn't have any of that. And it seemed like wasteful to me to spend money when I had baubles in a box in my house. So the baubles came back again. Thank you. Oh, okay. The baubles came back again. So instead of being threaded over my ear with the strings, they were now threaded through with the sleeper through the center. It's an excellent way to make an earring if you are rushed at Christmas. And so then I also discovered that you can add pom-poms to sleepers. Sleepers are a very big star in this story. And the good pom-poms that are made normal size are a bit big, but if you use a fork, you can make a pom-pom that is perfect earring size. I'm giving you all the tips today. You're going to go home and get all your forks out. Or you can have a very talented daughter. I have one of those. And so she can use oven-baked clay and made ramen bowls, honestly, ramen bowls with little what are they called? Eyelet screws that you can get from Bunnings. So you could attach an earring to the center of that. And so you are now going to go out into the world and look at things differently. If you are a TAS teacher like me, or if you just have a lot of junk in your drawers, which many of you do, nerds, you can use an eyelet screw to attach to anything that is a kind of malleable plastic or wood, and you can make like bugs. No, earrings do not have to match. This is a rule that has been applied to us for too long. If you have access to a drill, you can turn, and a paper clip and some pliers, you can turn some Lego bits into, this is a very bad angle. This was practiced on a flat surface. They do exist, and they're threaded. Or if you're like me and have laser cutters and 3D printers down the hall, and an SVG, you can make these. This is the logo of GPN. Everybody, we have the CEO of GPN here right today, and it's a very good organization. I have the shirt. And then we have 2 butterflies. They're not the most beautiful butterflies I've ever made, but then if you thread sleepers through them, even while your hands are shaking, you have earrings that I will be wearing for the rest of the day.
Thank you so much. Hello.
Hold up the earrings. One fell.
There we go. So we've all made mistakes, which will be relevant to our next talk. For the time being, Sean, if you're ready to go up next on this side. Thank you so much, Amanda. And we've all made mistakes. The AV's been a bit screwy already. I forgot which order this introduction goes in. But we're all apparently making mistakes with type hints. David's going to tell us about them.
So yeah, you're probably not using type hints right. But what are type hints, you might be asking? So there's these things, right? These are great for telling humans and tools what the expected types of everything is. So the most common mistake I see is just not using type hints. Type hints are great for documentation. You should use them. Sometimes people partially type in their functions. So what happens here is that the tools will assume that these can just take or return any type. You should probably explicit if this is intentional. But what's even worse than that are type hints that are just straight up wrong. There's about 5 different actively developed type checkers these days. Make sure you're running at least one of them in CI. So Python has containers, like lists, right? But what's this list that I'm taking here of? So collections, like lists, let you specify the types of values that they should contain. So yeah, this is great, but what if I want to allow passing a set of integers, for example? So the standard library does define a bunch of abstract collections, which let you say that these things can take, for example, sequences, which, so types like lists or tuples. Or in this example, I'd just say that this can take anything that might contain ints. So publishing packages to PyPI. If you have a keen eye, you might notice that this package that I have on screen is missing something. This does have type hints, but it's missing this file. So if you publish a type-hinted library to PyPI, you have to include this marker file for tools to actually consume your type hints. And you only need one at the top level. So yeah, don't worry about nesting. So here's some common typos that you might be making. So here, someone wants to return a tuple from this, this function. You need to actually use the tuple type. Yeah. Let's play a little game. function or type. So here someone's actually tried to use the any function as a type. Yeah, there's a separate any type, which you have to import and use. Yeah. The same deal here. Maybe you've written a decorator, right? Yeah, so this here is the callable function, not the callable type. So yeah, this is better, but yeah, you can also say what arguments a callable can take and what will return. But yeah. So here someone's tried to type into NumPy array, but if you've used NumPy, you might know that NumPy.array is a function, not a type. The type is actually called NumPy.ndArray, but you probably actually want to use the ndArray type from NumPy.typing for many reasons that I probably can't fit in 5 minutes. Similarly, PyTorch has a tensor type, but here this function is using the tensor function. Yeah. So thanks, everyone. This here is a QR code to the slides, if you need it.
Typing is a lot better than it used to be, but there's still a lot of things that can go wrong. Sam, you're up on deck on this side, but first we're going to hear about game development from Sean.
Thank you. So, hello everyone, I'm Sean, I'm a junior software engineer, and I got my start in programming with game development. And for me, I felt that my journey through game development has laid a really strong foundation for my programming skills, which eventually led me to the Wolfliner position. I also saw things go boom on screen that looked really cool, and I wanted to learn how to make things go boom as well. So today I'm going to talk about why game development is an amazing way to learn programming. And yes, my slides are a game. So 3 core reasons. Visual feedback, touching almost every area of programming, and solving fantastical problems. So number 1, visual feedback. I believe that visual feedback is integral to the learning process. It's an indicator of like what is going right and what is going wrong, but it's also something of a motivating force. I'm sure we've had those like uplifting moments where we do something and it works. And I'm willing to bet that those which had a strong visual reaction were the most like impactful. And games are very connected to this. They are usually, well, most often, very visual mediums. And so almost everything you do, anything you kind of implement, will have some kind of visual feedback attached to it. Let's take something simple as like making the player jump. Already what you're trying to do is reacting on the screen and have a visual feedback attached to it. Then you can make it better, maybe vary the jump a little bit so it feels a little bit better by varying the gravity and jump acceleration. And take it one step further by adding some animations and stuff. And throughout this process, visual feedback is always there. And so no matter what you do in game development, you will feel good about it, which will then help keep you motivated and keep you moving forward in the things you want to learn. Next is touching almost every area of programming. Depending on the game you kind of make, you can touch different areas such as databases, graphics rendering, networking, hardware integration, low-level GPU optimization, just to name a few. Games at the end of the day are just software. And they're also not bound by any particular framework or tool. In fact, technically, anything can be a game as long as it's, well, a game, an interactive system of rules and goals that engages the player in a playful manner. The idea of making a game just gives you the kind of structure you need to keep yourself motivated and to give you direction. For example, you can say, I want to learn SQL, which is a little bit daunting. You don't really know what you want to do with SQL, and it's very vague. You can instead say, I want to learn SQL to manage my game's inventory system and database. You now have a way to kind of apply what you want to learn and direction, and hopefully make something cool and visual out of it in the end as well. So if you always had that kind of one thing you want to learn, maybe make a game out of it or incorporate in the game in some way as a motivating factor. And finally, my favorite part, solving fantastical problems. Games are not bound by the chains of reality. You can basically do whatever you want. I mean, how often do you get to solve problems like, how do I flood a city with ducks? How do I build skyscrapers out of cake? How do I make a PyCon talk into a game? Games can range from being wacky to realistic, and by their nature, you will exercise your problem-solving skills quite extensively. So, maybe my ramblings have kind of inspired you to maybe also start making games yourself. But where do you get started? Well, as mentioned before, you can use what you already have. Whatever framework you want to learn, whatever kind of thing you want to incorporate, conceptualize it in a game, and you can kind of go from there. You also don't need to worry about graphics rendering as much. Some simple ASCII art or some formatted text on a CLI can go a long way. For more Python-related things, Pygame is an excellent choice. It will handle your graphics rendering, audio handling, and input handling as well. And otherwise, if you want to go one step further, you have game engines, which will also handle stuff like physics, collisions, particles, and other things that might be useful in the game. I highly recommend the Godot game engine because its scripting language is almost one-to-one with Python, and it's also open source. So, games are an amazing way to learn programming because they provide visual feedback within the development process itself. You touch almost every area of programming, and you get to solve fantastical problems. With that said, go make games.
Thank you so much, Sean. Some of the best lightning talks have information as well as a fun little trick up their sleeve. And as soon as we saw, I'm going to talk about game dev, but the slides are a game, we had to accept it. Up on this side next, we have Ada. But first, Sam Bishop is going to take us to a land down dunder.
It wouldn't be a conference without a pun. So yes, for anyone who hasn't worked this out at some point, when Python programmers are talking about dunder, we're talking about these double underscore things. And you might have come across some of them, but I'm going to cover these ones first. These are not dunder methods. Do not get them confused or ask me why I didn't include them. Name, main, and a few others, they are not them. I'm not going to bother. I'm moving on, because I've got 100 of these to cover. Such as init, which is something most people have covered pretty early on in learning Python. It's how you make classes. I'm not going to keep explaining. Then there's repr, where you start having to go, hey, what's this object thing? I'd like something more useful, and you make a custom version to make that easier for yourself. Then you get to the ones that people use a lot for typecasting, like when you need to have a custom string, int, float, or lesser often complex or Boolean output for what your class does. And then there's bytes and the much, much more infrequently used index, which is actually called when you're trying to use it as a reference for indexing. Then there's the math ones, like comparisons. So we've got our greater than, our less than, our greater than or equal to, our less than or equal to, our equal to, and our not equal to. All of these are hidden behind dunder methods. If you want to mess with how Python treats them, this is how you do it. And then there's the same thing for all the arithmetic operators. Now, that's a big old list of 8 by 3, and they are all just variations on the same theme. We have our add, our right add, and our in-place add, which are, is my thing on the left, my thing on the right, or am I doing it with the weird in-place operators? And that's just addition, subtraction, multiplication, division, modulo, integer division, exponentiation, and matrix multiplication. And then we have our Boolean arithmetic operators. So we've got our left shift, right shift, and or and XOR, same deal, same kind of pattern. We've got our value conversions, absolute value, negative value, positive value, and invert, along with our truncations, truncate, floor, ceiling, and round. Now that I've finally gotten rid of all of the math except one, we've got the weird little side call that is divmod, which most people never use. They'll just kind of do it twice. But that gives you your output in terms of your integer division and the overflow. Then we've got the fun stuff starting now. We've got our context managers. So enter and exit, as well as a enter and a exit, are how the context managers work both in synchronous and asynchronous style. If you customize these, you can do your own fancy setup logic, like spin up a database for a test, or tear it down when you're done. I've written async managers that spin up whole Docker environments in order to run unit tests. These things are pretty powerful. They're very, very powerful. You've got the container type methods, which most people, again, don't tend to play with too much, except for when they're playing with fake dictionaries. So you've got your get item, set item, delete item. You've got the reversed. If you want to customize reversing the list, maybe it's a bad idea to reverse the list in memory for, say, 10 million items or something. And you've got contains, which for the same reason, maybe you don't want to check that whole list. You've got length and length hint, which again, to use the same theme here, maybe if you've got 10 million items in your list, you don't actually want to count them. You might want to do a smart algorithm kind of guess, and length hint is how you can do that quickly. You've got missing, and that's used when it's like, hey, I didn't find it here, what do I do now? And then you've got iter, which walks through them all one at a time, and the asynchronous a-iter. You've also got next and a-next, which, speaking of iterators, are how the iterator protocol works. They basically just spit out things one by one. You've got get attribute, get attr, set attr, and del attr, which are how you do the attributes on a class. If you want to delete a thing on a class, the dot something, that's how you do it, as well as setting new ones, getting ones, and the get attribute is called all the time regardless, so you can get very powerfully into messing with other classes and subclasses that way. You've got new and get new args, which are actually controlling how you create classes. Then you've got instance check, subclass check, and class item get check, which are actually able to mess with the metaprogramming again still. Same thing for set name and init subclass, because why wouldn't you want to mess with the subclasses someone else makes from your code? Then you've got prepare and init subclass in here, which again, more messing with your children and the code that way. This stuff reduce is only normally used in making pickles, because you don't normally don't know what you're passing in, but it's there for that. Format is how you change what Python does when you run string format on things. Again, not usually the way you do things. Hash is how you make things hashable for use in sets and dictionary lookups. Size of is how you pretend that you're smaller than you really are. Await is how you actually say, no, I swear I'm going to get back to you later in an async context. Call is how you pretend to be a function even though you're a class. And finally, dir is actually how you list off all the attributes that are available inside your object, or just lie. And that is the 100 of them that I was trying to get through.
Thank you. Thank you, Sam. That talk will certainly help me and many of my other colleagues in this room be better men at work in Python. Hey, Jack, you're up on the other lectern. But first, I'm sure there's a bunch of undergrads in this room. If you want the rest of your year at uni to be more like lightning talks, Ada is going to help you.
Cool. Hello, my name is Ada, and today I'm going to tell you the story of how my friend and I used Python to get everything we needed to know from our university lectures without ever watching them. So here's my co-conspirator, Jeannie. Together, we made Compendio, a tool for students to make the most out of their lecture videos. So you give it a link and instantly get structured summaries, ask questions live, generate revision questions, and dig deeper into the parts you really want to know about. No more passive learning on 2 times speed again. So, how did this happen? Now let's go back to 2021. We were 2 university students learning how to software engineer. And as a rite of passage, we discovered this adage. Never spend 6 minutes doing something by hand that you can spend 6 hours failing to automate. So, setting the scene, picture this. University is fully online. We had several hours of lecture recordings to catch up on, tutorials and labs, which is where the real learning happens, a group assignment due that weekend, and a global pandemic. So we're faced with the choice. Do I work on my assignment? Or sign up for the 24-hour university hackathon that same weekend? And there we have, Can the Summarize My Lecture was born. So the hackathon theme was education, and we wanted to summarize insights you can't get just by skimming through lecture slides. So we decided to focus on the interaction between lecturers and students. So we focused on a specific problem. Could we match questions asked by students in the live chats with real-time answers by the lecturer from the recording? So we used a heuristic. We noticed that lecturers would usually mention that they had a look at the chat or so-and-so had a good question, repeat the question from chat, and answer it immediately after. And that's how we built our first summarizer. We matched on a trigger word, like question. We used fuzzy wuzzy, yeah, that's the name of the library, to string match the next sentence from the lecturer, like a boss. That's in the official docs, against chat messages from students. And then we just asserted that whatever came next is the answer. It worked pretty well. So then, during our exam period, we were faced with another choice. Do we study for exams with our new tool, or write a 5,000-word blog post for fun? And there we have Summarize My Hackathon. So you can check out my website for the full hackathon story. But now, must address the elephant in the room. You fast forward 2 years, 2023, and you guessed it, LLMs came out seemingly out of nowhere. So OpenAI released its first API for developers. And at this point, I wasn't even in university, but I still loved learning. And also, I kept getting these weird videos from my friends, like the dark side of home building, what they don't want you to know. I kind of wanted to know it, but not enough to watch a 32-minute video on it. So what do we do instead? Oh yeah, we'll bring back Summarize My Lecture. So Jeannie and I decided to extend the product. We used Fast API, LangChain, and Vercel, and learned a bunch of new concepts like vector databases, RAG, really cool, conversations, and we made Compendio. So put in that long YouTube video and get a list of all the non-compliance issues mentioned in the video about home renovations. And we also tried it with like 2-hour public lectures, like Introduction to Supply and Demand. Kind of just want to learn for fun. So the other thing we did was, well, this is actually pretty cool. So we decided to put it in front of users and deploy the site. Costs money, but get people to try it out. And then we watched as people used the website and clicked around. So it was really cool because we got an iterative process of improving the tool. So we noticed that people wanted to go to that part of the video when they get answers. So we added structured summaries with timestamps. The other thing that I found really fun was trying to make it faster. So LLMs weren't that fast at the time. We started with caching, so videos are stable. If you're watching lectures, there's a bunch of people watching the same video, so we cache the summaries, and we cache transcribing the transcript. We also stream chat messages. Instead of waiting for the response, just give it as it comes. And then we also realized that you could anchor expectations. So I replaced the loading symbol with watching video in 2 times speed, and suddenly 20 seconds to summarize a video is really fast compared to 2 times speed, 2-hour video. I also learned about mirrors and elevators. So when people complained about the speed of elevators, designers realized you could just put mirrors in there. You check your hair, and bam, you're on level 13. So we added some distractions, like what questions can you ask beyond summaries, and had other ideas like showing other videos that were summarized. So it's now been 2 years since we built Compendio. It's now in archive mode, and I learned a lot from building it, more than watching the equivalent of lectures in the time spent. Thank you very much.
Thank you so much, Ada, for carrying on the tradition of winning a little bit of work by doing way more work. Up next on this side, we have Justin. But for the time being, last year, Jack Reichelt managed to squeeze 18 animal facts into 5 minutes. This year, he's set himself a more modest goal.
All right, so I'm just going to talk about just the one cursed animal fact. Yeah, as said, last year I had more facts. I have a favorite fish. This is not the cursed fact. There are lots of good fish. There are plenty of good options for what your favorite fish might be or what my favorite fish might be. Is it the hammerhead shark? No, very cool, not my favorite. How about the barrel-eyed fish? Those green things, those are its eyes. They look up through the transparent head. Very cool, not my favorite fish. Maybe it's one of these fish. They're good fish, but they're not the best. My favorite fish is really smart. It has interesting social habits. It displays evidence of tool use. I like it enough that I even have one at home. I like it so much that about a year ago, I paid a professional photographer to take a bunch of photos of me and my favorite fish. Here is me and my fish. What? Am I a fish? Yes. Sorry. Let's learn about phylogenetic bracketing.
Stop!
If species A belongs to a group, phylogenetic bracketing is a tool used in bioinformatics and a bunch of other fields. And basically, it can be used to identify a bunch of different traits or categorize different things. If species A belongs to a group and species B belongs to the same group, then their earliest common ancestor is also a part of that group. You cannot evolve out of a group, and so all their descendants of that common ancestor are also in that group. This means that if the hammerhead shark is a fish, and the barrel-eyed fish is a fish, We can look at this tree of life and see the blue line for the hammerhead shark, the red line for the barrel-eyed fish. We can see where they meet, and the humans are on the green line, which is along those lines. So humans are a fish. Humans are a fish. There are lots of other fish you probably didn't know are fish. The snakes, cows, frogs, dinosaurs, fish. So what is the actual physical evidence of this, apart from just me showing a graph? Your eyes are fish eyes. What I mean by this is the lens in your eye, the refractive index, closely matches water. They are evolved for seeing in water. Now, you might have opened your eyes underwater and not seen very well in water. We have adapted extra things to make them work out of water where we're not supposed to have them. We've attached a whole bunch of little muscles around them, and we're constantly pulling on the lens and distorting it and such. This makes them work in air now. It also means that your eyes get tired. Fish in the water, their eyes don't get tired. Fish on the land, their eyes get tired. Your eyes are fish eyes. In the opposite direction, a fish's swim bladder is just a lung. The lung evolved first, not the swim bladder. The lung is a very fancy and weird part of the digestive tract. That's why it shares the tube and you can choke. Don't. But that's why. If you've got an area that can absorb nutrients, it can also absorb oxygen. Put that off in a bubble somewhere, seal that. Hey, now you've got a swim bladder or a lung. And lastly, you have a jaw. Everything with a jaw is a fish. If we go back here, you might have noticed that those three lines all converge on the jawed vertebrates. Congratulations, you have a jaw, you are a fish. Everything with a jaw is a fish. Not every fish has a jaw. There are two families of fish that don't. The hagfish and the lampreys. If you've ever seen a picture of one of them, you might go, that is a weird looking fish. That is definitely true. And so, the one cursed fact that I have for you is every terrestrial vertebrate is a fish. Thank you.
I happen to be sitting in relatively close proximity to a trained geneticist, and I have not seen someone wincing that hard in quite some time. Geordie, you are up on deck on this side. Jay is going to talk to us about radios.
Thank you very much. Good afternoon. My name is Justin Smallwood, but as you are all my friends, you may call me Jay. This is my preferred name. And today I'm going to tell you about how we're going to save radio astronomy using some Python. First of all, a little bit about myself. I'm currently a PhD student at Swinburne University. Before that, I had a 7-year career in finance. These are some of the nicer names I was called during that time. And before that, I have degrees in economics and mathematics from the University of Melbourne. So, why does radio astronomy need saving? Well, first of all, here is a pretty typical radio astronomy observation. On the y-axis, we have the frequency. On the x-axis, we have time. And the pixel intensity is how strong the signal is in that particular frequency at that particular time. As you can see, we have a bit of a beam going down the middle. This could be from a black hole. This could be from a pulsar. This could be from many curious cosmic things. But I'm more interested in the bits that we've cut out. These are bits where the data has been corrupted by what we call radio frequency interference, or RFI. And the problem is that if we do nothing to stop these entering our particular things are going to go badly. And this is why. So here I've got a little image, and we've got our little telescope in the middle, and what we really want to observe is this blue signal. But there are things which are getting in the way. For instance, this red one in the sky might be a satellite or a plane, or this one on the ground might be a cell tower or a microwave oven. And these things are also going on our telescope, and they're getting into our data sets. And the problem is that if we do nothing, these white regions that have been cut out are going to grow and grow and grow until there is nothing left. And I've even blocked out the citation at the top, because if no one's getting any data, no one is getting published. And so, how are we going to solve it? So this is Murray-Yang. This is the Parkes telescope. If you've seen the dish, this is the dish. And I'm particularly interested what's at the focus of this dish. This is something called a phased array feed. And there's a zoom in the little left-hand corner. And each one of those little checkerboards is a receiver. Instead of one receiver, we're now using 200 receivers. And what this means is we can use the arrival times between each of these different receivers in order to figure out which directions things are coming from and to get rid of them, which is great. So we're going to mathematically filter out this interference using a branch of mathematics called spatial filtering. But we have a problem. The data velocity is huge. We're talking about the order of terabytes per second. So really, this has to be done in C++, CUDA, running on graphics cards at the telescope. So how am I using Python to help me do this? Python use 1. I'm making small interactive applications to simulate and understand the mathematical techniques that I need to apply. And Streamlit is something that's really, really good for this. There's a little link to one of them on my website, but essentially this lets me simulate different signals, apply the techniques, and mess around with all the sliders and things and make graphs which look completely unintelligible. But this helps me understand the techniques before I then go and apply them in a really high-performance environment. The second way that Python is helping me save radio astronomy is to shorten the develop loops when I'm actually writing C++ code. I'm fairly new to C++, and so this helps me figure out what I'm going to do before I actually have to go and do it in C++, and that helps me. So that's a really good use of Python in my opinion. So where is all this going? Well, at the end of my project, what we're eventually hoping is that we turn this into this.
Thank you so much, Justin. So up next on this side, we have Toby Lovett. But for now, Geordie is going to tell us how we can shove 8 graphics cards into one computer without starting an electrical fire. Take it away, Geordie.
So a lot of ML and AI workloads depend on 2 things, Python and GPU power. But the thing is, GPUs are only getting wider, and half your slots end up under the damn card. So what you can see there is a photo someone has leaked to me of the GTX 6090, which my sources say will try and draw twice the power through a power connector half as thick. But yeah, what can we do other than being dependent on cloud services? Maybe we just need some extension cords. But what could possibly go wrong? So a little warning here, you are opening Pandora's box. The smaller PCIe slots are only rated for 2.1 amps or maybe even half an amp. Times 16 high power cards can actually pull 6 amps out of the slot, and all of that comes from 2 pins on your 24-pin motherboard power connector. So 3 cards on the board and you'll be breaking that limit. Also, if you stick a card on a riser cable, it's not screwed down. If it hits your metal case, you're going to short circuit things, and not that I've done that, but the slot does still work afterwards if you add a riser to it that provides power again. So there's a lot of pins here, but which ones do we really need? So 12 volts, 3.3 ground, supply them at the remote end. Ref clock, most devices actually do need that with some exceptions. PCIe reset, most devices do need that to start up properly. And lastly, there's 2 differential pairs for each lane. So 1, 2, 4, 8 or 16 of those depending on what width of link you want. Trouble is, this is all practically RF. It's like 10 gigahertz in terms of signals. Corners might have been cut somewhere. It's not really just a matter of connected. You need a very good signal between both ends, but your motherboard vendor probably cut some corners. Your card vendor probably did too. The newer PCIe modes run on much tighter margins, and sticking a bunch of wire in the middle is not helping. So there's no guarantees. Expect some frustration, but that just makes it more satisfying when it does work. So crypto miners love large clusters of GPUs. What do they use? Wait, what's going on here? Well, that's not actually USB. It's just using the USB 3 wires. But we want more than a ×1 link. Machine learning and AI, we put a lot of data in and get a lot of data out. We're not just trying to guess a number. So speaking of USB, we got Thunderbolt or USB 4. good option for getting cards on a laptop, but you can only put one of those in your PC and it's still only ×4. At the other end, your choices are a little sketchy or quite extremely expensive. And I've heard Intel doesn't really like these things existing anyway. So you go on eBay, you search for the right cables, ribbon risers. They're generally the most common option, no external power. The good ones are even shielded. I did not have very good luck with these, especially when they were longer than 10 centimeters. So that one, yeah, good luck with that. It's probably going to drop you to PCIe 1.0. But can we get more than one device on a slot? So bifurcation, it's not actually a feature of PCIe. Your motherboard's chipset or your CPU is programmed to say which lanes go to which slot. We just change that, pretend there's multiple slots, get a card like this to alter reality to match the software, and then that's got 2 downstream connectors to go to 2 × 8 links, and yeah, that actually borrows some variant of a SAS connector because like previous one, it's not SAS, but we're just using the connector. So that usually lets you split it 2 ways into 8 and 8 or 4 ways into 4, 4, 4, 4. You can't really go below that. Your BIOS might let you down by not having the menu option visible to actually select that on the slot, so you just decompile it and poke the right value into the EFI variables with RU. Simple, simple, but surely there's a better way. PCIe is packet-based, switches. And there's even some cheap options. You don't just get 2 downstream × 8 links, you get 4. With the right software, you can even reconfigure this thing to get it into ×1 or go much further. So then how do you get that to a slot? Breakouts. Note the SATA connector, only 2 amps. Also, we're supposed to have some pins connected up there. It doesn't. No one actually cares. It works. This one, bit of a problem. You can see on the right. Yep, they mirrored the pin out. So what we have to do is move those things up there by doing surgery on the cable, and then it works. Fortunately, ref clock's only 100 megahertz, practically DC. This one has the lanes backwards, but they got the rest of it correct, and it works.
Thanks, Geordie. I think. Alex, you are up on deck on this side. Toby is going to talk to us about data structures.
I will quickly preface this with, if you happen to be in the audience and you're my father, you're not allowed to comment on this.
Seems unlikely.
What are the chances? Last year I had a friend over who had some strong opinions on the cleanliness, or perhaps lack thereof, of my room. You know, fair enough, I'd just moved. It was covered in clothes and shoes and boxes and push bike and plastic and other things. But that's not what I want to talk about. Last.fm is a music stats website for nerds. Any nerds in the audience? Woo! It keeps track of every song that you've listened to across platforms, across everything, and it lets you see collections of this. It lets you see exactly what you listened to and when, and it lets you see this for your friends. Despite Last.fm having a recommendation system already in it, I decided I want to do it myself. It's very programmer coded, I think, to say this thing already exists, but I want to do it worse, but for more effort. Now, in the process of downloading all of this user data, I'd made a mistake with the API, and I wouldn't realize this for a couple more weeks. But it led me to an interesting moment that I think is helpful for teaching about some data structures. Because of the mistake I made, I was getting some overlaps in when I was paginating these downloads, and I couldn't really see where the overlaps were starting and finishing, and so I just had to check, here's the new songs that I've got, and here's every other song I've ever downloaded, which was regularly hundreds of thousands of songs per user. This is what a list looks like basically, in CPython. We've got one item here, and it's very easy to see if there's any overlap. If I'm looking for a song, I can see if it's right there. But if I've got lots and lots and lots of songs, it becomes much harder to go through every single one and check, is this song in here? Is this song? Lists get very time-consuming for checking, and I was checking every page against every item in this list for every user, and it was adding minutes and minutes and minutes to my downloads. Didn't want that. By the end of that, I had kind of come up with the idea that I needed to do something differently, and so I said, sets. Sets are a much better structure for what I'm doing here, because, and somebody much smarter than me can correct if I've misrepresented something, but what we're doing is instead of doing a list of items, we just put everything there. And we can see that each of these spaces will represent a specific song, a specific ID, a specific something. And we can populate these and very quickly just look at it all at once and see if it is there. So when I'm trying to download my songs, it becomes almost instantaneous. It went from a few seconds per page to I didn't even notice it running. So this is good, and I actually ended up just putting everything into a set because sets are unique. You can see here that there's no 2 spots per thing. We can just store unique items and everything into a set, sort it at the end. Now, my final aside is that now that I've got my recommender working, you can DM me. Here's my link. I don't have a QR code. It's not very good at recommending, but you're welcome to ask me for it. You will need a Last.fm account and a few hundred listens to get anything good from this. Now, with all that being said, I think there is actually an obvious takeaway from this. My room isn't messy. It's highly optimized and efficient for finding unique items quickly. And finally, does the data agree with me? Okay, fine, I'll clean my room.
Thank you so much, Toby, for giving me a plausible explanation for why my apartment looks the way it does. Up on this side, we have Alan Rubin. But first, so some of you may remember in the pre-pandemic PyCons at Lightning Talks, we had some presentations about history and politics. This year, it's a full-blown conspiracy.
Arnott's ginger nuts are not equal, so there's actually 4 of them. Arnott's bought out many bakeries between in the 1940s, 50s, and 60s, and well, they kept some of them because basically what happened is, well, they tried to go to the Arnott's queue and then people hated it because why would you want the New South Wales ginger nuts queue? It's just bad. So anyway, this entire situation happened, so I was curious after this. After I came home from a road trip with some friends, and we arrived home, and all they had in their pantry was a packet of ginger nuts. It wasn't quite right. It was like, it tasted weird. The texture was wrong. Turns out it was a South Australian skew. So as everyone would want to finding out this conspiracy, I would want to find out where I can buy them. So obviously I had to reverse engineer the Coles online API. Like I looked at Coles and Woolworths and I went, Coles is easier, so I just went with that. So I queried their API 10,000 times because per SKU, because I didn't know what stores actually existed, because the API required a store. So I just tried every integer between 0 and 9,999, and I found about 800 stores. I probably queried their API probably about 110,000 times. But they earned, well, $1.1 billion in profit last year, so I don't really give a slide them on. So then I went to go, oh, I've got all of these stores. I don't know where these 800 stores are. So I looked at the easy option and went, oh, where's the click and collect location near me API? And then I realized and decided to expand the amount of stores it would return and the distance. And it didn't work. It turns out they have a hard limit of, well, distance, like kilometers and amount of stores returned, so that wasn't feasible. So I ended up going digging and found this random, really internal-looking ASPX webpage. Unfortunately, it was quite outdated, and it includes lots of pick and pays and a BILO, a former BILO locations. And I looked up one, and it was actually an IGA now, so I guess they sold it off. So obviously, that's not feasible. Like, I was missing a large amount of stores that I knew existed because I had stock amounts for all of them. So I just found another API. Like, I can't find it, but I went on Google, searched Coles locations, and I found a page for a particular store. And turns out they had a redirect on for most store locations using on their old store location page, except for this one store. So I found their API. Turns out they've since killed it. So you can see up the top left, the top right, that's the result that I got in May 2014, and now it's dead. Oh well. So I still wasn't happy. Like, I still had quite a few stores that I didn't know what it was. So I found another free APIs, because of course I did. So I found all of this data. Now, how the hell do I display it? So I started this entire project because I wanted to learn Python. I'd never done Python before, and well, there's a lot of everything in this thing. So I'm like, okay, I'll have a look. And I ended up finding GeoPandas and created a static plot. But I went, no, I don't want that. I want to be able to explore the map. I want to zoom in because this is kind of not workable. Like, I can't tell which stores in Melbourne have what because they're just one pixel. It doesn't make sense. It doesn't work. So back to the drawing board. And then I also looked at more tutorials and found out that GeoPandas actually has another thing for like I think it's called Explore, and it just uses Folium, which uses generates like a leaflet map, and well, you can just do anything, and you can export it as HTML. So I did. So then I created a. Yep, there we go. If I can do it right, I now have a thingy in the top corner. I don't know what to do.
It's okay, we can read that.
There we go.
Stop.
So I made a web page about it. And
that's it. That's your 5 minutes.
So some things to note that... are we at time?
Yeah,
Yay.
so Garth, you're on that side. I mentioned earlier that we had a geneticist in the room. Jack, I think we've got a response to your talk. That is what you're doing, right, Alan?
Sure, now
yeah, let's go with that. Okay,
okay, maybe tomorrow.
Alan, everyone.
All right, thanks everyone. I'm going to tell you about genomic data standards. So first of all, here's a cartoon of a DNA molecule. We're talking about genomics. We're going to talk about DNA. DNA stands for deoxyribonucleic acid. It's how your genome is encoded, and that's the blueprint for all the cells in your body. I hope many of you saw Nick's talk this morning. It was really great. So DNA is a polymer chain made up of what we call bases, and each base is given a letter, A, T, C, and G. And we can now sequence DNA very efficiently. So here's a picture of a DNA sequencer. It's an instrument that fits on a benchtop. I found this one on AliExpress. I'm not sure if it's any good because there weren't any reviews, but it uses nanopore technology. So you can use these instruments to read out the sequence of any DNA molecule, and we usually represent those as text strings of A's, T's, C's, and G's. And so we store those text sequences and some information that comes off the sequencer using a file format called FASTQ. But usually we aren't actually really interested in the sequences themselves, but rather how they are compared against another genome or how they're different. And so variant calling is the process where we take these sequences and we compare them against a reference genome to identify differences. And when people talk about how scientists sequenced the human genome in 2003 or so, they're talking about the human reference genome. And that's and that's represented by this little database icon here. And the human reference genome isn't one specific person. It's about 70% of it is an African-American man from Buffalo, New York, and the rest is other people. And so this is the genome that all other sequences are compared against, and so that's what we're going to use as the basis for the variant calling. It's complicated, so we're going to hide it in this magic black box. And the output of most variant callers is what's called a VCF file, which stands for variant call format. It is the most cursed file format I have ever worked with, and I am not going to talk about it anymore. But we want to be able to talk about individual genetic variants, and so that's the change in the genome with respect to the reference. And so one of the most common formats for doing that is this HGVS format, which was originally defined by the Human Genome Variation Society. You'll find HGVS everywhere. It was in Nick's talk. It's very common in clinical reports from genetic tests or in scientific papers. You can also find it on the AliExpress listing page for DNA sequencers. Here's an HGVS string. It has a reference succession, which is the sequence we are indexing into. Here, this is human chromosome 19. It has a prefix that tells us what kind of sequence variant it is. Here, this is G for genomic. We have the position for the sequence and then the substitution in the reference base. So this is a C to T at whatever position that is. HGVS can represent a lot of variants. Here's the same variant in the genome showing with respect to a transcript. That's a coding variant. And with respect to the protein, that's these p-dot variants. So the DNA format, as you'll notice, is really different to the protein format. And that's by design so that you can't easily confuse them. And so HGVS is very flexible, right? In fact, be too flexible. So here's an example where instead of a version transcript or something from a database, we have a gene name. It's not specific anymore, but it's still valid, and it's actually much more interpretable. The most popular clinical reporting software creates HGVS variants that look like this, since it's much easier for our clinicians to see the gene name rather than the accession number, because most people don't memorize gene accession numbers. Here's another example of a valid HGVS string for a large DNA rearrangement involving an insertion and inversion of a sequence with uncertain breakpoints. You do not want to have to write a parser for this. It is very challenging. There's an HGVS package that parses these strings. It's open source. It's written in Python. It uses context-free grammars and a large sequence database to do this work. If you are a fan of context-free grammars and railroad diagrams, you are probably at the right conference, and you will also probably enjoy reading their reference documentation. There's a lot of beautiful stuff in there. To the best of my knowledge, there is still no software implementation that covers the entire spec, and I believe the first version of the spec was released in 1996. It is also very hard to pass this around via API and compute on it. I did write a regular expression-based implementation of a tiny portion of the spec that we needed for a project. I think it is terrible. We are still using it in production. Also, because we are open source software developers, there is also a PyHGVS on PyPy, which has not been updated, I think, in 7 years. Don't get confused. Now, to try to solve the problem to allow us to do things like build database APIs that can talk to each other more easily, we have a different standard called VERSE, or the Variation Representation Specification, which is much more recent. It's from an international standards body called GA4GH, the Global Alliance for Genomics and Health. When Nick came to one of our meetings, he said it reminded him of the IEEE. I don't know if that's good or bad. Here's the verse representation of that same variant. It is punishingly verbose, but it also makes it much easier to validate and parse these objects. So the reference implementation of verse is also in Python. It does not use a context-free grammar. It does not have any railroad diagrams, but really complex variants can be built up and composed using things like JSON schema to make these complex variant objects. But you can't easily paste this into a clinical report, so we still need HGVS for a human readable version. And so of course there's an XKC for that, but I think this is different because it's really an example of how we do need different standards for different purposes. And we need standards for people that people can read, and those should be systematic, but we need different standards for computers. So maybe this problem of needing to juggle multiple standards for different use cases is also true in your work that is maybe not in genomics, and I'm interested in talking more about how you manage this. So thank you.
Thank you so much, Alan. Also, as someone that has been fighting with Russell Keith McGee for the title of the person that speaks the fastest in this conference, I'm worried that the two of us have a third contender. Up next on this side is unfortunately nobody.
Oh.
Up next on this side is unfortunately not a lightning talk presenter. I am told that our conference director is not nobody because Peter will be closing the event. Fortunately, there is one more lightning talk to go. One of the really interesting things about lightning talks is some of the really deep metaphors and the ways that we can connect technology with the rest of our lives. Garth Kidd is going to tell us how to get a blowfly out of a bedroom.
How do I follow that? Quickly, right. Thank you, Benno. Right, how to get a blowfly out of a bedroom. I am here to tell you how to get a blowfly out of a bedroom. I regret I was mumble old before I finally figured this out for myself. Quick poll, who here already knows how to get a blowfly out of a bedroom? Why didn't you tell anyone? Right. Theory of operation, as a co-worker of mine might call it, or as I started calling it whenever it's a bug, theory of failure. There is a fly here. Now, I drew this blowfly. This blowfly needs work. It's a bit David Thorne. It's only got 5 legs. So I've asked people to help me with my blowflies. Thanks, Althea. But this question needs work. How do I get the fly out of my bedroom? It's misleading in that it sort of leads you off into like considering methodology before you understand the problem. A better question is, why is the fly here? Thank you, Lily. And this might just be for verbal processing types, but does anyone have that thing where they just keep mulling over a question with this mate and the other, or if they're really unlucky, the same mate over and over? And they keep asking the same question over and over in different ways until they finally find themselves expressing the problem in terms of the solution? This is a much better question. Why doesn't the fly get out of my bedroom? And the answer is regrettably obvious. It's dark. That's why it keeps flying into the walls, going and can't see to get out. The reason it's in our bedroom is it followed us here. Or, better put, it followed the light here. And now that you understand what happened, the methodology is obvious, right? Thanks, Maya. Sorry, I'm changing blowflies repeatedly and I'm failing to give credit. I'll fix that at the end. So what you do is you walk out of your bedroom to the next room out and you turn the light on. And you wait until the fly joins you. And then you move to the next room along and you turn the light on there, and then you walk back to the other room and you turn the light off. Lather, rinse, and repeat. I ran out of blowflies at this point. This is my blowfly again. You lather, rinse, and repeat until you lure the blowfly to the most distant point of the house from your bedroom. And then you turn that light off. And tiptoe back to your bedroom. Too long didn't read. Lure it out with light. And I'd like to thank my blowfly collaborators. And thank you for listening.
You done? Oh, thanks, Garth. That was great.